ENV 220 final project, Tijuana River Estuary. My name is Trevor Welch, and today I'm going to present to you the facts and data that I have collected regarding the estuary. So the Tijuana River Estuary is located in southwestern San Diego County, and it's right along the U.S.-Mexico border. Spanning about 2,500 acres, this protected coastal wetland is one of the last intact salt marshes ecosystems in Southern California. The elevation ranges from about sea level to 10 feet, making it especially vulnerable to tidal flooding and pollution inflow. The climate is Mediterranean with a warm, dry summers and mild, wetter winters, conditions that support a unique mix of native species. The surrounding land includes urban development, military installations, recreational trails. The estuary supports a rich diversity of life. Its plant life includes pickleweed, salt marsh, bulrush. It also serves as a habitat for endangered and migratory species such as the light-footed Ridgway's rail, the California least tern, and as hummingbirds, various herons, egrets, and amphibians. The site is recognized as part of the National Estuarine Research Reserve and plays a major role in the Pacific Flyway for migratory birds. Unfortunately, it's heavily impacted by pollution, particularly sediment and raw sewage flowing from upstream in Tijuana. As part of this project, I'm evaluating the estuary's current environmental condition and assessing how a proposed residential development could further affect this as already stressed habitat. My goal is to provide the data that will help guide more sustainable development practices that prioritize the health of both the ecosystem and the surrounding community. For this part of the evaluation, I used the Carolina biological test strips that came in the labs to measure pH and turbidity to assess water clarity. These are standard field tools we use in our course labs. I collected water samples from 2 estuary locations and tested them on site. pH levels will help determine the water is too acidic or alkalinity for the wildlife, while turbidity indicates how much sediment or pollutants are present. Both tests evaluated the impact of pollution and habitat stress. For test 3, I used the Carolina Biological Dissolved Oxygen Kit at the river mouth to assess how much oxygen is available in the water. DO is essential for fish and aquatic life, and low levels often indicate pollution or excess nutrients. I followed the kit instructions, matched the color samples in the chart, and recorded the results in milligrams per liter. For test number 4, I measured surface water temperature using a digital thermometer and a handheld thermometer at both sampling sites. Temperature directly affects oxygen levels. Warmer water holds less oxygen and can increase stress on aquatic species. These 2 tests work together to help me understand how the temperature and the DO influence the overall health of the estuary. To gather my data, I collected surface water samples from my 2 locations in the estuary, Goat Canyon Channel and the river mouth. I utilized Carolina biological field tests for pH, dissolved oxygen, turbidity, and temperature. Each test was conducted on site and recorded the results immediately, along with notes on the weather and visible conditions. One limitation was that I couldn't test for chloroform bacteria or other lab-based indicators due to safety concerns and equipment availability. Another limitation was that the recent rainfall and sewage overflow events may have temporarily altered water quality, indicating that the results might not reflect long-term trends. This graph compares 4 water quality parameters: dissolved oxygen, pH, temperature, and turbidity, measured at the Goat Canyon Channel and the river mouth on March 16th and on April 10th, 2025. The data shows a slight drop in dissolved oxygen at Goat Canyon in April, likely related to a recent sewage discharge reported in March. Just last week, over 5 million gallons of raw sewage were being dumped into the river daily due to infrastructure issues over in Tijuana. The pH has also dipped slightly at that location, possibly due to the increased organic waste and runoff. At the same time, we observed a rise in turbidity at both sites, which may reflect sediment or stormwater flow entering the estuary. The temperature rose slightly between March and April at both sites, which is expected with seasonal changes. Overall, these data reflect how water quality is influenced by both natural cycles and pollution events, highlighting the estuary's vulnerability to human activity and environmental stress. Now, these charts I got directly from the Tijuana River Estuary research team, which I do volunteer work with. We do field work. I actually had to walk through that water with safety gear on, but these graphs show very interesting changes over the past 10 years in regards to anoxic days, the DO levels, and the transboundary flow. So this is the raw sewage in here on the right. During one of my volunteer contributions to the Tijuana River Estuary with the research team, they shared these graphs with me, and I found them crucial to share this presentation as they highlight key points to the existing harm to the ecosystem. These visualizations emphasize why further residential development would be detrimental, given the already significant pollution challenges. There are several actions people can take to improve both the Tijuana River Estuary and reduce the harm we cause. Restoration efforts like moving invasive species and planting native vegetation can help bring back ecological balance. Improving wastewater infrastructures on both sides of the border, not only here in the U.S., but Tijuana needs help too. And managing stormwater runoff would also reduce the amount of pollutants reaching the estuary. On a community level, small actions like reducing foot traffic in sensitive areas, picking up trash, and installing educational signage can go a long way. The more we educate the public and involve local volunteers, the better chance this habitat has to recover and thrive. Conclusion. The Tijuana River Estuary is currently under significant environmental stress. My fieldwork revealed high levels of turbidity and nutrients alongside visible signs of habitat degradation. Invasive plant species are competing with native vegetation, and the water quality data points to pollution from upstream sources. Despite these challenges, the site still holds a potential for ecological recovery and the right interventions. This isn't just an environmental issue, it's a public health concern. Pollution in this estuary doesn't stay isolated. It can affect the surrounding neighborhoods through contaminated water and airborne toxins and degraded recreational areas. Communities near the estuary, especially those already undeserved, are more vulnerable to these impacts. This situation highlights how closely linked environmental and human health really are. To promote long-term sustainability, we need to take a multi-layered approach, restoring native plants, removing invasive species, and improving the wastewater infrastructure on both sides of the border. They're all essential. Just as important, community involvement, public education, cleanup events, and binational collaboration can empower people to take action. With consistent effort, we can protect this vital ecosystem and the people who depend on it.